Marcia. I'm chapter president for the St. Louis chapter of CSI. Tonight's presentation is on preserving your building. I would like to thank Sika Sarnafil and Chip for sponsoring. They sponsored our food tonight, so thank you very much. We had a nice day. Chip, you want to say anything?
Well, just for those online, you should be here. The food tastes better when you actually eat it.
Yeah.
Okay. I'll say for 30 seconds my elevator speech. I've lived my life in Division 7, thermal and moisture protection. It's the most important division of all. The roof is the most highly maintenance required item that a building owner has to spend money on. So let's start with a good roof right away. Sika Sarnafil PVC. Thank you very much.
Thank you. Thank you. At this point, I'm going to introduce Derek Marshak, one of our directors and part of the Kelley group.
Oh, yes.
And let him introduce our speakers. Thank you.
Thank you. So I'm going to keep this really short so we can get to the good stuff. I'm going to introduce two people, and I'm not sure that online is actually going to, well, you will see them initially. First person to present is Jeff Kelley, president of Kelley Restoration. Basically, I'm going to let him talk about exactly what he does. And the other is Cale Prokopf, president of Roof Tech and Pave Tech, to talk about the roofing side of things. So with that, I'm going to let them get to it.
Very good.
Thank you.
Well, thank you for letting us be a part of your program tonight. You know, we're going to talk a little bit about inspection, maintenance, and restoration. I'm with Kelley Restoration. We're part of the Kelley companies. Kelley's a large company here in St. Louis that is a general contractor. They have civil group, industrial group, paving and concrete group, and we're part of the restoration group. Nice thing about our program is you can see up there at the top the little R up there for our little logo by building in the parking garage, but actually we could work on about any one of these structures. And I always tell people, estimated project managers looking for work in our industry, when you drive to work every morning, you look out the window of your car, anything you see is an opportunity for us, because anything that man built, we get an opportunity to restore. So that's great for our business. A little history about myself. I've been in the industry for over 30 years. I worked for a large company here in town you guys probably heard of, Western Waterproofing. I started as a trainee estimator project manager and retired there in 2017 as the president. So I've had a long career in the concrete and masonry restoration business. And another gentleman in the office, Kyle Burns, same thing. He came from the same program, had 20 years experience in the garage restoration. So he primarily was focused on garage work for most of his career. Our services, we do the general concrete maintenance, concrete structural repair, waterproofing, specialty items, and some specialty roofing products. Just two slides on some of our typical projects, typical concrete restoration projects that we perform. And pretty much most everything up there you see is really all due to some type of corrosion, lack of maintenance in most cases, and which we'll be getting into more tonight. Probably only one slide on protective coating there at the bottom left hand. And really a lot of this starts with us just by going out and taking a look at a parking garage or structure and really identifying the different conditions that exist, and generally those conditions lead us to whatever the next step would be, and it's usually some type of restoration and then a maintenance program. Project up here at the top, it still has to do with some type of water problems. This particular wall, retaining wall, was having issues because of this drainage system was undermining the footings, washing the concrete out there, and then having structural problems with the wall. So we came in and created a new wall, actually built a steel cage, shot gunite, air place concrete, and then stabilized that wall and put a new drainage basin in. Over here is a typical condition we'll find where the concrete's deteriorated, the steel is deteriorated. We have to basically remove the concrete, put in new steel, form it, pour new concrete, put a protective coating on. And then this particular owner was doing some maintenance, had a protective coating on, was on probably for 10 years and decided to go ahead and do another coating on top of that and continually maintain the facility and get a new warranty on that. And then that's just some typical concrete work we do. So enough about us. Let's talk a little bit about the concrete business in general. Why is concrete restoration a multi-million-dollar business, annual business? And well, let me preface this as well. So if you guys have any questions about my statistics, I'm going to tell you right now, it all came from Google, so we can find that anytime you want. You guys have, anytime you guys want to go ahead and look and check me out, you can see it on Google. But an estimated 9 billion yards of concrete placed over 20 years ago. So tell me, there's a lot of concrete out there that's old and therefore needs repairs, especially the concrete structures that there's been minimal maintenance or no maintenance. And then right now they're estimating over 500 million yards of concrete placed every year. So this is going to continue. There's a lot of concrete that's old and out there, and we continue to place more concrete every year. And therefore it's estimated as an $18 to $20 million industry as far as the restoration industry in the U.S. So we look at it as it all starts with a new construction. The point of new construction really is the opportunity to, it really determines the quality of the project and how well it's going to last. And we're really starting out with, we're going to consider it's a good design. So as far as we're concerned, the design's good, and now it's going to be about the installation. And we think there's some opportunities at the point of installation that if there's a good inspection process, that some of the problems that we generally see can be minimized and save the owner a lot of money down the road on the restoration side. But some of the three main areas of concerns that we find in a garage is going to be concrete cover. We all know that there's a certain amount of concrete that needs to be over the steel to protect it from water, salt, etc. The other is over finishing or the mix. You know, that if you add too much water to that surface, and a lot of contractors like to put a little extra water on there to finish it, and that creates problems. And the last was the drainage piece. Where's the drains? And I thought there was a plumbing company up in Omaha, Nebraska, where I'm from, and I'd always ask them, say, Dan, which is the problem here? How come there's always ponding water in the garage? Is it the drain's too high, or is the concrete too low? Is it the plumber's fault or the finisher's fault? And of course, you always said it was the finisher. But there's always, seems like there's drainage problems. And so ACI calls for a certain amount of steel coverage, and you can see in most cases they're asking for 1.5 inches, 2 to 3 inches of coverage, and you'd be surprised on how many projects that we find the steel is 1/2 inch, 3/4 inch under the surface of concrete. This certainly could be caught at the time that the project is being constructed, and a big problem for an owner down the road. There's a lot of old parking garages out there that has minimal coverage. I think people do a much better job now on the quality control and inspection to minimize that problem. Typical garage, we'll see the ponding water, whether it's the drainage in the concrete or the actual drains themselves, maybe not enough drains, and a lot of times owners will have us come in and look for core holes in the concrete and auxiliary drains and try to get that water out and displace it so you don't have the ponding water. I guess another issue during new construction, these are things that really can be inspected and minimized to help prolong the useful life of that structure. And then the scaled concrete, you know, we all seen that cement truck out there, and the guys are putting a little more water in and spraying it, and you put too much water on the top, change that cement ratio, and you have that problem. So those three elements, I think we find on more garages than anything. There's certainly other problems, but those are probably the three main problems that we see that contribute to corrosion. So then let's talk a little bit about the concrete material itself. So concrete building material, you know, it absorbs water, it's porous. It gets hard, it shrinks, it cracks. And the last one that lasts forever, right? At least that's what we all thought. Concrete lasts forever, and a lot of people felt that way, and they didn't do a lot to maintain it. They didn't have a maintenance program, and then they find out that it lasts a long time, but it comes at a price if you don't do any maintenance. But being very porous and cracking is a real problem for a material that does last a long time and is a good building material. And for those of you guys that like to get into the details, there's a little information about why concrete is porous. We get these capillary pores up here, and it does allow access for water to get into the concrete itself. Even though it looks like the size of the pores are pretty small, it's still, if water sits there long enough, it can penetrate into the concrete and create problems. So what's the best friend for a concrete restoration contractor? All these cracks. So if concrete's porous and it's going to let water in over a period of time, what's going to accelerate that is all the cracks in the concrete, and you'll get cracks in there for a variety of reasons. However, if those cracks, if you don't address the cracks, it just allows the corrosion process to start in and accelerate by letting the water get in and et cetera. So an owner could really minimize the problem by taking care of these cracks and having some kind of maintenance program. So it gives you kind of an idea of cross-section of the concrete and the steel itself, and so you have your nice new concrete with no problems. And then as moisture starts to get into the concrete, for a variety of reasons that we saw above, you can start that corrosion process. Eventually, that steel starts to rust, and as it does, it'll create a force that's stronger than the concrete, and then it'll create these falls. And this happens to be a downward fall, but you'll have an upward fall as well. And that's just pretty common in the industry, but we'll see that. So then you say, well, what can we do about it? Why is that such a problem? And really, it's accelerated. If you're in the Midwest or you're on either coast, you really look at the environment that we're in. As soon as it snows in the Midwest, of course, we bring salt trucks out, and then the trucks put the salt in the street, the cars drive, and they come park in the garage, the snow falls, and now we basically apply fluoride to the garages. And then you get the ponding water, and it sits there, and then eventually it works its way into the steel, the slide that we saw above, and the process continues. Found the same thing on either coast with the salt air. There's a lot of balconies out there. You go down to Florida, and you're going to find a tremendous amount of concrete restoration work due to the same principles there of the salt and chloride being introduced to the concrete. And I talked to a gentleman at Sika a while back and talking about where their business is, and I think their biggest market is New York, and they said one of the top 2 or 3 other markets is southern Florida. And I thought, well, why is that? The population in California is pretty large, and why wouldn't that be in your top 2, 3, 4 areas? And he said, due to the number of buildings that you see in Florida. In Florida, the buildings look like this. In California, they got some mansions sitting on the hill, so you don't have as much concrete being exposed to the concrete. You might have a bigger population, but the actual structures that are being exposed to the salt and chloride is higher in Florida. Therefore, we sell a lot more repair mortars. Did you know that? And then it gets to the freeze-thaw cycles. So you look at that and you say, okay, so now we have these cracks, we have the exposure to the elements, we have the chloride, and then you look and say, all right, how many freeze-thaw cycles does that structure actually go through? And the last 3 or 4 years, the average has been somewhere between 90 and 120 freeze-thaw cycles. So that moisture gets in there, water gets in there, freeze, and those cracks start to get bigger and bigger, and it just allows more chloride and salt to get in and do its thing. So you can see, of course, the southern states, especially the ones that are away from the ocean, have very few freeze-thaw cycles. Maybe up in the coastal area here, there might be maybe 20 freeze-thaw cycles in a year's time. And then you go to the Mountain V area, and that might be it's like pink, and you can see, we all know what the weather's like in that area, and therefore the freeze-thaw cycles are going to be a couple hundred. So it definitely makes a difference on the condition of the concrete. I guess if you want to be in the restoration business, this wouldn't be the best area for you right here, at least from the chloride contamination freeze-thaw cycle. So we talk about what do you need for corrosion. I guess we all know what that is, steel, water, and chloride. And are we really doing enough to minimize the amount of water and chloride that gets into the structure? The steel's already there, you have to have it. The concrete doesn't perform, the structural concrete without that steel doesn't perform well, so you have to have it. And then if we can't keep the water out and the chloride out, the corrosion process is going to happen. So really for us, if you want to talk about maintenance for an owner, this is the process that they really have to focus on. Because at the end of the day, you get the rust, you get the corrosion, and this is typically what you'll see in a garage if the owner does no or very minimal maintenance. And I can tell you this is common in any one of those cities that basically have salt trucks and you're using the chloride, you're going to see that almost in every parking garage in any city. And I can tell you St. Louis, I could probably name half a dozen garages that look like that right now. And then you wonder, should you be able to park there? And it's amazing that I guess from a design side, you know, what's the factor of safety? You're going to add times 2, times 3, but they seem to perform, and the engineer comes in and creates a spec and bid on and fix it, and actually the garage performed very well after that. So really what our goal is trying to reduce the corrosion process, and by doing that we need to reduce the moisture, the exposure to the elements, eliminate chloride, and then somehow protect that concrete. And so how do we do that? How do we go about reducing the moisture? You know, concrete is porous, so you're really not going to change that. So you have to make it so that it's less permeable. So how do we keep the water from getting in? And some of the things that we found that work well, I think the industry knows that the number one thing you can do is probably right here, the annual inspection. So if every owner were to go out and walk their structure, I don't care, you know, as a homeowner, you really need to do the same thing. You're going to have problems with your home where water gets in your roof, your windows, etc. These buildings and structures are no different, but some owners do a great job of inspecting their facilities, or they call an engineer and have an engineer come out. They'll call a contractor to come out. But the number one thing to do is inspect the facilities and find out that you have a problem. This piece here, this spring cleanup, pretty much every garage owner with a plaza deck, any type of concrete structure that is subjected to water and chloride, you really need to get that chloride off that garage and do a spring cleanup. You go out there and blast that, water blast that garage of concrete clean. I always give the property managers a hard time and tell them I'd come wash their garage in the spring for free, and they get all excited. They say, oh yeah, we'll wash every garage you have for free. But I said, I'm going to use water and chloride and mix that up and clean your deck, and they kind of laugh at me and say, no, I don't think we want you to do that. But at the end of the day, that's what they have. And so if an owner will do that, wash that chloride off the deck, they'd have a lot better chance of having a garage that's going to last longer. The next thing would be something minimal, probably the most cost-effective item that somebody can do is just route and caulk the cracks. As we saw above, when those cracks occur, and then you have the freeze thaw, and they get bigger, and they allow water and chloride in. If you can do a simple thing, just taking the grinder and they route that crack out, and they put urethane sealant in there, something flexible that can move a little bit, that'll stop the water from getting down to the steel, and that structure will last many years. The other thing is going to be replace the deteriorated sealant, which can be control joints in parking garages, and they're going to eventually go bad. The useful life of a urethane product is probably about 8 years, and so it can be, the original construction can be a good job, but after 7, 8 years, that product's useful life is over, and it really needs to be cut out and replaced. Good owners will be doing those inspections, will catch that, and then they'll tear that material out, put new material in. So if they do those two things, clean the garage, and then do the route and caulking, you're in pretty good shape. Then you, down the road, 6, 7 years, replace the caulking. And really the number one thing you could do for a parking garage, if you wanted to give it the best opportunity to last the longest, increase its service life, would be putting a deck coating on. A urethane coating that can cover the entire garage. So you're basically eliminating water and chlorides from getting into the concrete. And if that happens at day one, that structure will last many years. Unfortunately, a lot of times, an owner, maybe it's a developer builds it, they don't put that on, they defer the cost of the coating, and then they get the building 80% occupied, they decide to sell it, and then the garage 20 years later, the next owner is realizing now I have problems, there was no coating put on, the maintenance has been minimal, and they find out they have $600,000-$700,000 concrete restoration project, and then they end up putting the $300,000 worth of coating on at that point in time. Or if they would have put that on when they first built it for maybe at the time $150,000, they would have saved a tremendous amount of money over the 20-year span. But that has to do with the owner, or the long-term owners, or the short-term owners, and those decisions are made that sometimes not best for the structure. So really the best thing you can do from day one is just spray a clear sealer on. So there's styling and siloxane sealers, clear penetrating sealers. You do that, and it minimizes the amount of moisture they can get from the concrete. The next would be this simple application here, just looking for the cracks. You can see these cracks are coming off these columns, which are typical, and find them, route them out, off them. Now they're sealed. That those cracks can reduce the opportunity for moisture to get in there. So the concrete overall is sealed, and then the cracks, which allow for moisture to get right down to the steel, that's eliminated. Those two items right there will add a tremendous amount of additional life to a concrete structure and reduce the maintenance cost. And then the premium is here, just putting the urethane coating down, and typically they're gray. There's other colors, but it looks like concrete. Put some sand in it, so it's non-slip surface. It wears well, and they're pretty clean. They're easy to clean. And then, 5-6 years later, sometimes longer, you can come back, clean them up, and recoat them, and just continue to protect that concrete. So the consequences of deferred maintenance, that's the piece that is talked about a little bit, that if you don't do the maintenance that we talked about, putting the sealer on, the route and caulking of the cracks, and putting the deck coating down, these are some of the problems that you can run into. And this is where it gets into the owner's pocketbook. So I think good owners realize this, and they pay a little more attention to this piece. But increase in quantity. So what do I mean by that? So when you're going out and you're looking at a garage and there's deteriorated concrete, the easiest way to find that is you take a chain and just drag a chain over the surface of the deck, and you'll hear a hollow sound. No different than if you're walking on tile and you hear that hollow sound, the tile is debonded. And the reason you hear that is because the steel rust has expanded, and now as you saw in that one slide, it creates that spall, so there's a gap between the top surface and the bottom surface, so it's hollow. So as you drag a chain across it, you'll hear that noise. And there might be 500 feet, 1,000 feet, 10,000 feet of deteriorated concrete. Just depends on the garage and how old and the severity. But that's one way to find out what you have. And so now you have a certain amount of quantities that you need to repair. But if you defer it too long, the depth of the quantities also increase. So today I might have 3,000 feet. I don't do any work for 5 years, so 3,000 feet might become 10,000 feet 5 years from now. So the amount of repairs increase. And then depending on the depth of the slab, the thickness of the slab, that can increase. So you have, depending on how many sets of spars are in there, you go down from the top steel to the bottom steel, and you have to keep chipping down to get underneath the steel to do the right repair. So generally in the industry, they want you to get down below the steel and to sound concrete, and if you expose more than half the bar, the rebar, then chip 3/4 of an inch under that bar. A lot of times that gets you down to another mat of steel, and therefore just have to have a deeper repair. The cost of the repairs per square foot go up. For instance, a shallow depth repair, let's say it's 4 inches thick, might be $35 a square foot. Now we're going 6 inches deep. We waited longer, the corrosion went deeper, so now it might cost $45 a foot. And then a full depth repair, where you got to go all the way through. So the concrete on the bottom side is bad, you might as well have to take it all out. So you chip everything out and basically form it and reform it. And as you can see, the cost of the repairs keep increasing. So this one is up here, you're doing more, and then these just, the type of repairs keep increasing and costing more money. And then the last one, overhead repair, that's probably most expensive just due to the fact that now a guy's chipping above his head to try to chip the concrete out, and it takes longer. So it's going to cost more, where if you're on top of the deck, you can chip faster and more efficient chipping down. So this is kind of an example here of, so a shallow depth repair would be here. Maybe this is at $35 and they're waiting longer, and and then it's getting deeper here, this would be $45. And unfortunately, now that you have full depth repair, that's the $60. So if the owner would have performed maintenance before it was this severe, maybe they could have minimized the repair cost by not having to do the full depth repair.
At some point, with that full depth repair, or maybe even less than that, don't you run into having to replace the rebar?
Absolutely.
And that's got to be part of it too.
Right. There's a certain amount of cross-sectional area, the rebar is gone, then they make you take that out, and then there'll be lap length on the rebar. Sometimes if it's corroded at this point here, you have to come back and get good steel and have a certain lap length on the steel. But yeah, it gets very expensive, and they'll come back with green steel, and they'll coat the steel with epoxy or some type of rust inhibitor. But as you can see, that the amount of work that goes into it increases, and of course, therefore, the price of the repair increases. And then the ugly one that you don't want to have is this soffit repair on the bottom side, and that's the $90 repair. And in a lot of cases, it's just cheaper. If this here is going to be 35 or 45, and the bottom repair, this is going to be 90, so now you're over $100 some for the repair. You're better off going back and just doing a full depth at 60. So in some cases, you don't want to do a shallow and a soffit repair and try to leave a couple inches of good concrete. It's just cheaper to take it all out, form it up, have a monolithic core, not having patch on a patch, and a lot of cases that happens as well. So a couple, I guess you can call case studies or situations where we've seen lack of maintenance and how it became a bigger problem for the owner. For instance, right here is an expansion joint, and on this side of the joint over here is a building, this side's a garage, and so you got a beam on each side below holding the building, the garage up, and the drainage for this in this garage runs this way. So we talked about drainage earlier and how important it is. So on this top deck, when they throw the salt out there and it rains, all that rain and chloride runs down here. You have this open joint, and so it runs down in the joint, and what's right below the joint is this beam line right here. And so this could have been, there's probably only 50 feet of joint there that maybe would have cost, could have been a $100,000 fix, and now you're going to have a couple $100,000 of concrete repair, not counting the shoring. You have to have an engineer come in and figure out what the loads are for the building in the garage and shore that up, because you're basically going to expose most of that bar, and so the beam isn't going to be able to perform, and so you got to have that cost in, and it's going to be quite costly just due to the fact that they didn't maintain the strain. Another typical example of lack of maintenance. So your mechanical joints. This is what typically happens in a parking garage when top deck put a mechanical joint in, and then the snow plow comes in, and they actually make these rubber boots that go on the snow plow so that it doesn't create this kind of damage. If your snow plow is just a steel blade and comes up and they drag it across the concrete, well, this isn't as hard as concrete, and it'll tear them up, and then of course what's generally on both sides of these joints is a beam, and then those beams start to corrode and they look like the one we saw on the slide before. And then of course now the maintenance done, there's a nice pretty joint, that's what it should look like, and this particular owner, if it keeps the joint looking like that, you won't have to do the concrete repairs on the bottom side. This is a precast parking garage, same thing. Talk about maybe lack of maintenance and the benefit of maintenance, but this particular garage, you can see that there's no coating around the perimeter of this garage, and where the precast tees actually tie into these walls, they have these support anchors here, metal brackets. You can see they're very corroded, heavily corroded, and so the owner wanted to then come and expose these and see what's wrong, and then replace the ones that are heavily deteriorated, clean them up, epoxy coat them. So you can see here, where no coating along here, no coating along here. The drainage runs this way. There's a drain right there. So all the water in the garage runs down here, brings the chloride down, and there's no protective coating here. There's a caulk joint along here that is breached and it's not caulked and allows moisture to get in. And so this water runs right down to these brackets here, these angles, and they start to corrode. And a typical repair on a precast garage, it happens pretty much all new or all precast garages, but if an owner were to do a little maintenance and make sure that caulking's in place, put a protective coating around the perimeter at a minimum, that would minimize the restoration or repair cost. Same thing on the precast at these joints where they have the weld angles of the weld pieces in there. Those, get some deflection, those will break, or the caulking will open up and moisture will get in and those will rust. Same problem. A lot of owners will just put coating over the joints, which is at a minimum, or you can do the entire parking garage. Now this particular owner, same type of construction, precast garage, you can see they put a coating around the perimeter. And so they were doing a little preventative maintenance, and you can see this particular coating was down for about 10 years. So this is at least 10 years old, and you can see they're starting to get some wear on the coating, and actually they're wanting the price to recoat it because it needed it. And then you can also see these red dots. They went around and every place they saw cracks, they put those red dots on there. So they had the engineer go out and identify the cracks, and part of this package was to route and caulk those cracks. You can see this was probably done in the past. They wanted to keep up with their route and caulking. They wanted to bring this coating back to life, and then look what the underneath side looks like. So their support angles here, not corroded. They look very good, and this is probably 20 years old, and looks great. Where this one, it's not as old as the garage, and it's in much worse condition, and there's still many brackets in this garage that still need to be chipped out, cleaned up, exposed, and at some point they'll have to put that coating around the perimeter. So you can really see the difference of doing the maintenance and not very minimal work here, other than some miscellaneous caulking, and then redoing the coating. But they basically on this garage they've eliminated all of the concrete restoration. And so ultimately, that's what you get. If you put the coating down at the beginning and you maintain that coating, you get a garage that really looks nice. The soft with the inside will look nice. And of course, I'm using some pictures that are making the garage look really, really pretty. But at the end of the day, if you do that, you will have a nice garage and you'll minimize the maintenance cost, and the cost of ownership goes way down. And then I think there's been some discussion, what about, some failures, and have there been any garage failures? And I can tell you that in the 30 years that I've been around doing it, I know I've heard of a couple here and there, but nothing really significant. I don't think that's a problem. There's some garages that are probably borderline. I've seen some garages where the engineers have come in and said you had to shore up some levels, and they shut some levels off the parking, but they've been in programs where they were caught and then shored and shut down before they had failures. But I think a big piece of that, a big reason for that is we have some conscientious owners, and maybe a big part of it is just because of the dollar side that we showed you, when a shallow depth goes to a full depth, just the price of the repairs. If you're not a good owner and you don't do the maintenance, but the price to own that parking garage goes way up, and I think people realize that, so they don't want to be in that position. And then this one, the other one, is these cities and municipalities are really creating, they're making it so that there's inspections on these garages in most cities. And, a few examples like Kansas City, every 5 years they would go in there and they inspect the garages, and the structural engineer has to come in and inspect it, and if there's some deficiencies, they make you fix those. New York, local law 7, same thing. It's on a building as well, but it's saying anything over 6 stories, you have to have an engineer get on the building, inspect it, make sure that it's structurally sound, and if not, you have to make those repairs. And fortunately, say for instance in New York, it's not every 6 years, it's 1 year, 2 years. So the building is in a rotation of every 6 years. So it's not as if every 6 years every engineer has to get on a building in New York and ride a swing stage. But if you think about the number of people walking around, brick falls can be a problem. Same thing in the parking lot. So it's nice for our industry, at least from a contractor side, on the restoration side, that the municipalities are going to make sure that these garages are safe. And if the owners don't want to do it, the municipalities are going to make sure that it does happen. And I think that's why you don't see a lot of failures in parking garages. And then there's a couple of websites you can go look at, and there's some firms that identify several cities that have these same programs. So that's kind of that's the piece on the concrete, so we'll talk a little bit about the masonry side as well, and this will go a little quicker. It's basically the same criteria that you see in a garage is gonna be similar that you'll see in masonry building or facade. But the workmanship issue is still a problem, no different than concrete, so whatever can be caught during new construction is really gonna save the owner down the road. And the maintenance is just as important on any vertical facade as it is on the horizontal structures. New construction, we find problems with the flashing, the walls, the lintels, wall ties, wall cavities, the mortar, seal the weep holes, and movement. These would be typical problems that we would see. For me, the movement side would come a little later, but I generally see a lot of cracking due to movement. Cracks in the masonry are problems that we typically see. Cracks in the mortar joints, deteriorated sealants, parapet walls having problems, flashing, and then you allow that moisture into the building, you're gonna have the same problem where, especially the older buildings that were built in the early 1900s, if you have a crack in the building that's allowing moisture in, it gets to the structural steel, that steel's going to rust, and you're gonna have the same problem. You know, on projects where you pull out the actual lintel or columns, beams, and there'd be holes in the steel, they're so old and deteriorated. And at that point, you got to shore it up, take those pieces out, put them back in, and you lay that masonry back up. A lot of those old buildings had a crack, a vertical crack that would run at the corner. And because one side of the building, the sun would be shining on it, and the other side would be in the shade. So this side wants to expand, and the other side wants to contract, and you create that moment at the corner. And so the building kind of wants to pull itself apart and create its own crack. And so we would have to go in there and basically allow the building to move there and put a expansion joint on that corner and let that corner move. I think that's probably kind of practice now versus back then it wasn't. And these would be typical problems that we would see on masonry buildings where the owner would not do the maintenance. After a certain period of time, when that mortar starts to go, then the same thing with the freeze-thaw cycles, the moisture gets in there and starts to pop the masonry. Here you see the face of the masonry coming off, so the brick gets porous and face comes off, water gets in there, and it just keeps on to pop that brick off. Usually the wall ties rusted on a masonry unit where it's basically not going to hold the wall in place, and you typically see this right here. You can see that caulking line. And so the wall ties are bad, and the building's starting to move, and the masonry's bulging right there, probably about an inch. So you have to really pull that, and take that masonry down, rebuild it. In some cases, I don't think we're this far out, you can drill in the mortar joints and put some anchors in to hold that in place. And this is pretty typical of what you'll see on lintels that a lot of times people will caulk the lintels and hold the water in so that the water can't get out when it rusts, or the lintels might be even set back a little bit where it retains water. The flashing in there's not adequate, but this is pretty typical. You'll see in a lot of old structures. And typical masonry and rusted steel that we talk about more different than concrete. You can see this particular building has a lot of brick masonry problems. There's some terracotta units down here. And these joints are all open, allowing moisture in. And this is the angle that actually holds up the terracotta. And the anchors here that go back into the concrete beam, these are all rusted out. So at this point, any of this can have a failure just due to the support angle that's holding everything up is tight into concrete, and the concrete behind it's deteriorated. And actually, this was a particular project where an owner contacted us and wanted us to fix the concrete beam going into a parking garage, and above it was this terracotta. And so when we looked and said, all right, the concrete, you have to chip it back about 6 inches or up 6 inches, and the anchor for the steel angle is going into that concrete. But when we chip that concrete, the angle is going to want to fall, and that's supporting the veneer, the terracotta veneer. So we told them we have to tear the veneer down so we can fix the beam. But as you can just see, there's a variety of different problems and this is all from lack of maintenance. It started with cracks in the masonry and not being repaired in a timely manner. So there's some things that in the industry, a pretty economical way of determining the amount of moisture that gets into a building is a Ryland tube test, and I don't know how many of you actually heard of a Ryland tube test, so few of you have. But it's really it's a pretty accurate test to at least let you know the porosity of the substrate that you're working with. So you can put this test on the brick face itself, and you just fill this vial of water, and you let it sit there, I think, for 20 minutes or so, and it will simulate a 60-mile-an-hour wind, something of that sort. But the head pressure that it creates will let you know if that building's taken in water, if it's going to need a clear sealer of some sort. And so you want to do it on the brick, and you want to do it on the mortar joints as well. So the question is, so what percent of a wall, of a typical brick, modular brick, what percent of the wall is mortar?
17.
17? You're pretty close. I think 20 to 25% is what I always heard 22%. I Googled it just to verify again, I got 20 to 25. When I grown up in the industry, I was told 22. But it is a big percentage of the wall, so if an owner wants to neglect the mortar joints, when it's 20% of what's going on there, that can be a big problem. So those mortar joints need to be tested as much as the brick surface itself, the face itself. And then if it takes in quite a fair amount of moisture, then you'll need to put a clear penetrating sealer on. So the late maintenance, the open mortar joint wall ties, and you get problems with mold and masonry, sagging lintels, rusted columns, and interior damage, and I think all owners have to deal with that. And so to me, it just seems like it makes sense to do the maintenance and eliminate these problems. However, people don't, and therefore that's one of the reasons we're all in business, to help people get rid of those problems when they delay the maintenance. The maintenance program here would be very similar. The annual inspection, forming the joints, sealing the windows, and joints, wet seal the windows. Find that to be pretty common on the aluminum glass structures where the gaskets around the windows, they get old and crack and shrink, and a lot of moisture into the building. And for us, there's most of those products we get to be 10, 15 years old. You're going in there, taking silicone and just cleaning that up and sealing the gasket back. And then put some type of protective coating on as well. But really, with most of these maintenance programs, the ideal thing is whether it's a garage or a building, is still to do some type of protective product once you complete the work to help minimize the effects later. Especially if you don't want to do an annual inspection, make sure you keep the building in good condition. So then we get back to that same public safety, and I think it's the same deal there. We talked about the local law 11. St. Louis has one as well on the facade, and you can go to those websites and find out about these other cities that have some type of ordinance to make sure that the buildings and structures are being taken care of. I know there's discussion about, okay, what happened down in Miami, and is that going to happen here? And is that every building and structure? I have to be concerned about that. Well, sure, I think we're all concerned about it, but truly in my time in the industry, I haven't seen a lot of it. We just haven't seen a lot of garage failures because of these issues here, or these regions here, these municipalities, and we do have a lot of good owners. And I think that's been beneficial. Just and seeing the difference of what you guys don't look about brick, but boy, it'll look a lot better to actually do it and versus the old and the new. So, summary of the benefits from the inspection and maintenance program. Anybody want to give me an idea of what's a good summary of why we want to do this, the benefits of it?
Money. Pay me now or pay me later.
Got a winner right there in the back. So, it really is. It's very cost effective. I mean, certainly from the safety side, that's a big concern. However, we don't see a lot of real problems where I don't think you get up in the morning and read that a building or a garage collapse. It does happen on occasion. The bridge in Minnesota, whatever that was, 10, 15 years ago, collapsed, and everybody gets excited. They're going to start a program, but for the most part, I think you do a good job here. So, I just want to say thank you. Appreciate the opportunity to present, and turn this over to Cale.
are we live? Can everyone hear me? All right. So my name is Cale Prokopf. I'm the president of Roof Tech Consulting as well as Pave Tech Consulting. Both of our businesses are third-party independent consulting firms. We do not repair, construct, or sell materials for that fashion. Roof Tech was chartered 21 years ago, predominantly as only a roofing consulting firm. As the industry has adapted, buildings have become more dynamic, and the need in the industry have changed. We've expanded into a full building enclosure firm. January of 2020, we chartered Pave Tech Consulting, which is basically the same thing that focuses on parking garages predominantly, as well as parking lots. So great information from Jeff. The one thing I do want to touch on with parking garages that we experience as a design and construction oversight firm is the downtime of the garages. Our clients complain a lot about that. We can't close the garage, it's costing us money. I think that compounds as much or worse than a delayed project for shutting down lines. So, within Roof Tech Consulting, there's a couple main pieces of our business. We call them pillars. And each one's a lot more dynamic than I'm going to let on. The first is assessments. We review full building enclosure, roofing, to put this into some sort of parameters. For one client alone, in 2021, we looked at 1,308 different roofs. Provided reports on that and assisted with maintaining those assets. The same year, we designed and oversaw the construction of about 80 remedial projects and oversaw the construction of approximately 50 new construction projects that were designed by other firms. So our belief is pretty simple. We believe that three main things need to exist for any project to be successful. The design has to be accurate, correct. We have to use the right materials, be it PVC or whatever it might be. Thank you for dinner. But within the design has to be right. Now, obviously, we're dealing with experts in this field, so we're not really going to have on that tonight. The second piece is once we have the proper design, the proper components, we need to make sure that the contractors are installing it perfectly. The design's right. Now we have to execute that design. Lastly is the maintenance piece of this. Jeff touched on a lot of great points on garages and the enclosure piece of it, predominantly masonry of the enclosure. I'm going to focus on this middle section because if we were to hound on roof maintenance and deficiencies, because of the different types of roofs, different components, this can last for 4 hours. So I want to focus our attention today on new construction and how our perfect designs are not implemented into the field. And then I'll wrap that back into that kind of third pillar I mentioned, which would be the maintenance piece of this. So we get the roof designed perfectly, and where do those faults come through thereafter. I kind of touched on this already. We're going to get into each one of these 2 slides. I'm a photo guy. I like to talk, you already tell. So we have our improper roof design, not an issue tonight. We have unsuitable conditions, which continues to get worse and worse. I mean, every year, especially in the Midwest, I mean, this is completely unlike last year, right? Rain, and it's continuing to be cold, it's warm. It's supposed to be 80 degrees by Friday. Improper materials manufacturing materials being used. One of the issues we're seeing right now with the material shortage, mix and match materials. It needs to go through a manufacturer, it needs to go through the designer of record. We need to approve these things. More importantly, we're finding people try to slide things under when nobody's paying attention. So we'll make sure we're watching that. Lack of communication between trades, some funny photos referencing some issues we've incurred there. Craftsmanship always somewhat of a concern. Nobody, I would say when the cat's away, the mice will play. We're getting some issues with QA there. And cold weather installations, again, resorting back to the weather what we're experiencing and what some of the material manufacturers have revised in the last couple of years without proper education to the installers has become a little bit of a hindrance. So we're going to start with substrate suitability. So when we walk onto a new construction job site, the first thing our qualified project consultants do would be the project manual with submittals to make sure that everything seems to be suitable from that standpoint, verify the materials. Day one, we're going to walk the job site. Now at this point, unfortunately, if we're on site, that means the contractor's on site, the materials are on site. The contractor's already accepted the conditions. And once they've done that, they're contractually bound to start that project and take ownership of this. It's not uncommon for us to find overflow drains mixed matched with standard drains, which creates an issue, especially in a tapered setting. Also the fact that overflow drains need to drain out completely differently, typically through some sort of scupper or exterior faced daylighted drainage. We see this a lot more often than we would like. The roof get installed, and we realize that the drains are mismatched. Another problem, scuppers. How many people go on commercial roofs in this room? A lot. Okay, great. Isn't that how the water always ponds where it shouldn't, specifically scuppers? That's really trade coordination. Although this is an older roof, it's probably been like that since the day it was built. The carpenter who installed the woodwork or the wood nailer or whoever cut the hole in the wall didn't understand the thickness or the dynamics of that roof. We like to sump these. This is a pretty simple fix. But unfortunately, whoever built the wall, whoever installed the wood, had nothing to do with that contractor that was installing the roof. The contractor installing the roof has to have some level of production and efficiencies. They're not going to stop what they're doing that day to revise that wood nailer because that's not under their contract to. This photo doesn't probably show what it should. We've experienced projects where the decking wasn't properly attached. It wasn't signed off on. The LT rep hadn't been on site to give his blessing. The roof goes down. We find out halfway through construction or installation that the deck is unsuitable. Well, who's at fault for that now? It becomes pretty complicated. Technically, it's going to be the roofing installer because they accepted the conditions. But I've never been on, at this point I have, but not many projects, on day one of a new construction site, the roofer is walking the decking to verify its attachment. And if they do they really know what they're even looking for? So we need to make sure that somebody signed off on this deck before the roof installation begins. This is a little bit of a dated article, but I don't want to beat a dead horse, but the moisture issue in new concrete, right? We all went through this. We want to adhere roofs to green concrete. Manufacturers didn't want to stand behind it. We have delamination, premature failures. This is a big issue. At this point, we're finding ways around this, different primers, different attachment methods. It's still an issue, but I think it's being addressed better now than it was 5 years ago. So improper material storage is a big issue here because right now as we get the rainings, we have some pretty stringent criteria on our projects of how these things have to be stored. We don't like them on the dunnage. So this shipping dunnage is just polyiso, the same thing we're going to put on the roof. It absorbs at a high absorption rate. We've actually found it sitting in areas similar to this, where 2.5 insulation boards up the bundle, it's saturated. It's absorbed that much water into it. So you've got to throw material off the job site. Sometimes material, especially now, is getting delivered on site and not being installed for 3, 4, 5 months. During that, it's becoming weathered, it's becoming exposed, it's becoming saturated and then dried out. I don't think most manufacturers are going to want that material that's been compromised to be within their roof assembly and covered under that warranty. We've also seen premature failures where the roof was examined, we come membrane back, we look at the cover board, the insulation, it's discolored. They can tell it's been exposed, and the manufacturers will walk through those steps because the material was not suitable when it was installed. These are things we want to be very aware of. Cold weather insulation. I want to beat this up for a second because this became a hot button about 3 years ago. So the photo on the left is pretty obvious. Unfortunately, we had a contractor on a large warehouse running and gunning, got to a Friday, ran out of membrane. Unfortunately, a lot of the insulation was left in place and the cover board. They thought they would make it through Monday. Unexpected storm blows through. We have this condition. It all has to be removed, disposed of. New insulation has to go down. Contractor's going to be on the hook for that. Regardless of what the forecast said, they own that material. It's no longer suitable. Photo on the right. About 3 years ago, middle of the winter, it was about 30 degrees for weeks on end, and we start monitoring these projects that we're a part of. We find out that in 1 week, 5 different contractors are starting projects in sub 40-degree temperatures. The rule of thumb in commercial roofing, anything adhered for the most part, is you don't install unless it's 40 and rising. There's different components that go into that, but that's always just the basic rule of thumb. The manufacturers had informed the contractors that they've changed their cold weather installation guidelines. Some of it varied, but for the most part, it was 25 and rising. Then, in 1 day, we went to 3 different job sites. Temperature was about 25 to 28 degrees. All 3 job sites were in St. Louis. At one of the job sites, the contractor had reached out to the manufacturer, and the manufacturer told them they can't install that day. You have my blessing. All 3 of those projects had to be completely skinned, and the roof had to be replaced. This is the component right here. So we did a lot of backtracking at that point. So where did things go wrong? What happened? Well, several of the major manufacturers had revised their cold weather installation guidelines. They made it a lot more, say, convoluted in the fact that the roofers are going to take any leverage they can to install roofs, to make money, it's what they do for a living. It become more of a, beyond just the temperature, we're talking about dew points, things of that nature. Some of the manufacturers by the apps are now asking for the field guys to basically become meteorologists. Verify things, check the weather, check the dew point, can we install today? Well, we've seen that's not the case. So as a designer, we went above and beyond and said we're back to 40 and rising, unless it's a very particular type of material. On this particular job here, the bonding adhesive still said 40 and rising. We checked them, we photographed it, we argued with the contractor that this is not suitable. We found similar buckets on site, exact same material, and they changed the label, nothing else, no formulation. Those are some ugly conversations. And unfortunately, we were the bad guy. We didn't tell them to install when it was 25. We didn't expect it, and to this day, we don't really allow it for that very reason. Improper roof installation. So, actually on this project, they had to install the bay doors, wind uplift become an issue, and actually tormented that roof. I think this one actually got insurance involved because it just basically started pulling fasteners out of the seams, mechanically attached EPDM. On the right, we designed to a particular attachment rate for any of our substrates in a metal deck or in a wood deck. These fasteners have a particular placement rate. That be a particular space from the corners, and depending on where your layout is, you're going to have some level of fasteners in the center, corners, perimeter. Fastening rates can go from 5 or 6 in the field, 8, 12, 16, as many as 32 we've seen, but there's a prescriptive methodology on where those fasteners are placed. This is not it. On a mechanically attached system, this would be a little bit more hidden. We can still find it. Fortunately, we saw this before the membrane was installed. But if a membrane was installed, fully adhered, this becomes apparent. So when you're watching roofs become installed, it's not hidden. It still becomes transparent. There's going to be some transparency through the membrane. Once the membrane is glued down, each fastener plate shows through. You can mark them, you can do whatever to verify the attachment rate. But if no one's doing in-progress quality assurance, check this fastening rate. This is a big deal, especially on FM insured facilities. A lot of designers are now designing to an FM 1-60 or an FM 1-90, just as a prescriptive attachment rate for roof performance. Doesn't really mean it has to be mutually exclusive with being FM insured. It's just a prescriptive methodology for attachment performance.
What I've learned, if it's FM insured, you have to do it the way they do it. If it's just designed to FM standards, each manufacturer might have been able to pass a less expensive attachment method.
You're exactly correct. So there's a couple other different performance measures, ASCE, some things like that about wind performance attachment rates. For example, when we design roofs, we typically reference an FM wind uplift performance and maybe an FM 1-49 for wood nailer attachment. We now have our own wood nailer attachment detail we've developed and provide. So those things to be very aware of. If it is FM insured, it becomes a little bit more complicated too as far as the submittal process. Some of the other things that are tied to this, having a roof nav, which is a pre-tested assembly. But, they'll walk you through the process. We're fortunate to have an FM office here in St. Louis, and they're great folks.
I just don't know if I understand what I'm seeing here, and I'm verified that I am seeing. Is the picture on the left, is that roofing, like,
Building.
Yeah. So mechanically, that's a great question. So in a mechanically attached roof, we're going to say that we have a metal deck and we have some sort of insulation that was installed properly.
right?
We're going to make that assumption. Okay, on a mechanically attached single-ply roof assembly, your attachment for your sheets is basically along your laps. Okay, it is designed to move and billow, but at some sort of extreme, typically during wind uplift, it'll stretch, where it'll actually pull the fasteners out of the deck. It'll never sit back down again. We hear this a lot. I don't hear as much anymore. We used to hear clients calling. If you can see a roof going down the highway, a windy day or a storm is blowing in, and there's a big differential in air pressure. The roof's blowing off my building. Well, it's not. It's designed to billow to some level. They actually perform uplift chamber testing at FM's facility where they'll force air under, kind of see how high it'll go before it does fail, before the fasteners fail. If it's a TPO roof especially, or a PVC, once it pulls on that seam, it's not rubberized, so it doesn't go back. That seam kind of pulls out, and you just can't correct it. There's no way to fix it at that point. On those white roofs where you experience this, you're walking across and it seems flat, you almost feel like you're being tripped, because everywhere there's a seam that's been pulled, you don't really notice it with the bare eye, there's a hump. So every 10, every 12 feet, depending on the sheet layout, you're going to have that little bit of a ridge now. On this one, again, this was a large industrial building. It had a ton of bay doors, and they had to install them. When they did that, we had a front come through, and it changed the dynamic pressure of the building exponentially, way beyond what this thing was designed for. Had the doors been installed, the same front moves in, everything should have been fine. This is something we don't really mark on a lot as a QA firm, but ponding water, especially in a single ply setting, one of the funny things, we talk about drain setting, that like first slide, this is our overflow, which is great. Also, it's sumped. That thing's always gonna hold water. And this is brand new, from 2018. But this roof wasn't even in service yet. It's already started to pond water. We can see from the rust of the granary. If that were up just another inch, the color could probably be adjusted. We're still meeting our 3 inch elevation for the overflow functionality, not an issue. We find a lot of designers and some owners, developers, really hang their hat. They don't want any ponding water whatsoever. Personally, I don't look at ponding water as some sort of mutually exclusive issue with the roof failure, especially now. This much is going to likely dissipate within 48 hours, which is kind of the rule of thumb if it's ponding or not ponding. If the water is gone in 48 hours, it's not an issue. We find this a lot too in improperly installed crickets or tapered systems, where it just runs into a wall, or maybe there was a belly in the deck. A lot more common in remedial, or where we experience wood deck. We don't see these bellies as much in metal deck applications or opposite concrete. Another issue, these are from the same project actually, low flashing heights. Before all of this is installed, we can run our flashings up this wall here. We can get 8 inches, 10 inches, as much as we want, really. We can make sure our air and vapor barrier or whatever's behind that wall overlaps the top of our membrane. We have a great watertight detail. What happens in 14, 15, 16, 18 years when this roof has to be replaced? Creates a nightmare. We basically have to start pulling off the sheathing and build up. We see this a lot. In remedial applications, we expect it. In new construction, this should not be happening. We should always have allowable flashing heights to allow for not only the installation to be proper now, but the installation to be proper when it comes time for roof replacement. Another big thing we encounter, we've kept the insulation dry. Everything's been installed properly. They're starting to maybe do some interior finish work. Now we're having penetrations arrive on the roof, punching holes. Well, it's not uncommon for those holes to be punched and not addressed, or flashed, or addressed properly. These are punched through, and they just used a sealant, like a Volcom around the base of it. That was fine. We also, unfortunately, find a lot of times they'll just use asphaltic roof cement, which doesn't play well with TPOs or PVCs, and you have to clean it. A lot of times we tell them to cut the membrane out. So temporary overnight tie-ins are a big deal. Also, if we're finishing the inside, we have drywall or finishes or flooring going down. If this leaks, if they install this temporary sealant and they think it's going to last for 6 days, 8 days, 10 days, 12 days, it probably won't. Also, we have a water intrusion issue on our new finishes. I love this photo because this is kind of what takes your eye. This kind of looks like a mess. Well, it's not. The issue is this guy, open right to the sky. So that should have some sort of a cap to it. So this was actually a leak on this project that was active. See this sealant here was installed. The contractor chased this thing down. They couldn't figure out what was wrong with it. It was that guy right there. It's not uncommon. What's also not uncommon is for somebody to run temporary wiring through something like this. So the roofer's been up, they've tied things in. We have a secondary trade come in and modify this condition to tolerate what they're trying to accomplish. The roofer's out on site, storm blows in, we don't have an issue. In worst case scenarios, we have a temporary tie-in that fails and the water actually saturates the roof, which can actually, depending on the finishes of the interior, be more detrimental. because now we have to tear out sections of the roof to mitigate the moisture in the water. And big issue here. So when we talk about the temporary tie-ins, we've all seen this, right? You've seen a job site, you've seen the membrane hanging over the side of the building, you've seen roof insulation, all these things exposed. And it becomes exposed for weeks and weeks until the other trades complete the work or the sheet metal contractor arrives to complete the detailing. We often find that these temporary type tie-ins leak. And we can see what's happening here. They left that. Snow's built up. Snow got behind here. Torrential pond inside this building. Here, for example, I actually took this photo about 2 weeks ago in Kansas City. This was totally saturated. If you look here, you can actually see the watermark of the insulation. I promise you that that insulation is still there today as the construction is continued.
It looks like fiberglass, is that what that is?
It's actually polyiso, just aged polyiso, unfortunately.
And it soaked up water?
So when we talk about absorption rates, this is a great question. Cover boards and everything all have different saturation rates, absorption rates. Polyiso will dry eventually if it's exposed. There's some questions about how it affects the R value, which probably making a mountain out of a molehill, to be honest. But if this gets wet, we throw our TPO membrane over the top of it. It's not going to dry anytime soon. And it will. I mean, I don't know. You know how long it would take to dry? You guys have run numbers on that?
I wouldn't think it would ever dry out. Is that ISO?
Not once it's
I
encapsulated.
thought it was supposed to be closed out.
It will become saturated. It'll hold just like a sponge.
Like things like EPS or XPS, one of them, we do waterproofing that is impervious to the water.
Yeah, so EPS is basically like your styrofoam cooler. That type of foam.
And that's what, that's,
But that, you don't have a compression rate with that, a lot of no fire ratings, a lot of other issues related to that. Obviously, polyiso is kind of our A1A of roof insulations currently. But this is very common, unfortunately. We see a lot. And this also ties back to our material storage. Again, it's wet. We've walked on job sites and just put X's on boards and had them remove it because they installed it wet or marginally wet. So it'll dry out. Like Chip said, unfortunately, it doesn't dry out, specifically when it's encapsulated. Talking about permeability, this TPO membrane, the impermeable. Obviously it's a waterproofing. It's for roofs. It's horizontal. So once you put that on the top of it, the moisture has nowhere to go. Yeah. So it'll create blisters. Even worse, saturated insulation will prematurely fail the roof. So sheeted TPO has three components for the most part. You have your underside, which would be black or gray. You have some sort of scrim, which is your reinforcement, and then your weatherproofing package, which is the outer part you see, which is white, gray, tan, or whatever color you choose. That outer waterproofing is roughly, I'm going to give and take, and this is different manufacturer to manufacturer, only about 20 to 23 mils of a 60 mil sheet. So once we start cooking that, day over day over day over day, and then we get excessive heats, and we're cooking this membrane from the inside, that's not what the weather package is. That's basically for structure of the sheet. That's where we see the premature failures. The membrane becomes brittle, starts to discolor. Your roof, there's an NRCA stat that the average commercial lowest slope roof in the United States performs for 14 years. Not 20, not 25, not 35, and all these crazy numbers we think the warranty means. But when you start doing this, that's why. I took this picture last week, unfortunately. This is a hospital. Never really had a final check. So we've done everything right. The contractor's done everything great. Handed the keys to the owner. Everything's occupied. Now you have these kind of phantom leaks. It's a checkout, right? It's not a big deal. We'll chase them down. This building had been open for 12 months. Nobody had ever done a formal inspection. They would spot check and run the leaks as they occurred. They didn't look down as they were walking those leaks. The first door we walked out of was right here. Every one of these was a puncture in the roof. You can almost see the puncture. It was that significant. It's really not that hidden. Right over what would have been in this area, there were about 8 more. One of them was the size of a quarter. Pushed it, water came out. This detail on the left was a canopy. And you can see it ties in some beautiful stone veneer. We have our weaves. They did so many things right. Other than the fact they never terminated it. Somehow or another, this is held tight for a year. With just a sealant base across the top of it, no termination bar, no anything. We're supposed to have a counter flashing. Everyone else had beautiful counter flashing. But it was a hidden spot on the project. It was a canopy, kind of tucked below another canopy, butted up against this beautiful wall. So it just wasn't really visible. It wasn't visible from the inside of the building. We were on the roof, we turned around, I just started laughing. And that would have been there until likely it peeled off the wall, it became saturated, it leaked. Now it's starting to deteriorate the underside of the board and chair, and we have bigger issues. So this probably $200 installation, or what would have been at the time of install or time of roof installation, would have created a lot more damage, thousands of dollars worth of compounding issues. So we talked about maintenance. As a third-party consultant, we do a ton of inspections, as I mentioned. So roof design and oversight, we by professionals. We do a lot of design, review of other people's design, because where a lot of designers have to worry about a million components to a building, we don't. We're very, very specialized. So don't take offense if we don't take offense if somebody wants to review our work. I would ask as a designer, don't either ask for help, ask for CHIP, ask for ours, there's other competitors, GW's here. Let someone else take a look at your work, make sure the detailing is correct, the systems are copacetic, the materials are copacetic. Right now, the materials are available. Designer involvement during pre-construction, we see a lot of submittals that come in that don't match the design at all. And the design is typically being reviewed, or the submittals are typically being reviewed by the GC or someone else. Things are being approved that the designer of record probably should be aware of. We see that way too often. And typically once the submittals are in, unfortunately the materials have been ordered, we'll kind of get the cart before the horse at this point. We have registered roof observers. I want to say we employ about 50% of the registered roof observers in the state of Missouri. Quality assurance. We talk about inspection, we talk about looking at things. We can all go look at stuff. My wife can go look at a roof. She's not going to catch the stuff in my clothes check. You need a trained eye looking at these things to make sure the fastener rate's proper, to make sure the counter flashing is installed. People have walked by all these roofs and missed things. So make sure you have somebody with a trained eye focused on making sure these things are installed properly. And then the communication piece of this is really between trades. I mentioned that early on. The trades need to coordinate. During these pre-construction meetings, not only the designer, but all the interacting trades, the sheet metal, the carpenter, sometimes even the deck installer, it could be the waterproofing contractor. They need to have some coordination and at least have one open communication with one another prior to installation. So the roof's installed perfectly, things are great. We find a lot of new roofs get installed and they're no longer inspected. I don't really get this. It's been paid to be inspected during construction, or if it's a remedial project, you paid somebody to inspect it for 10 years before it failed and got replaced. We put a new roof on it, $500,000, $700,000, whatever the cost may be, just keeps getting more and more escalated. Nobody looks at the roof anymore. And I compare it to the fact that when we buy new cars and we stop changing the oil, we don't. You have to continue this maintenance. You just made a huge capital investment, either a new construction project or a remedial project, and now you don't want to look at it anymore. So we have a pretty straightforward process. Our folks will walk the roof in a particular manner. We break down each roof independently. We have construction information, height, elevation, roof construction. One of the biggest misnomers is even in new construction. This project, like I said, 4 different roof areas on it. Each one can be different in construction. It's not uncommon for us to find an area of concrete deck where there's going to be some heavy mechanical and some areas where there's metal deck. On the same retail center one time, we found 3 different insulation thicknesses. Don't know why. Could have been a discount, could have been nobody was watching, who knows. But the construction can always vary. So this level of detail needs to be performed on each roof area, regardless if it's this size or just maybe a penthouse or an elevator. Once you've designated your repairs, they need to be clearly outlined and budgeted. And then for each roof area, your recommendations and budgets long term. As you mark deficiencies, the old way to do it was you write things in a report, maybe take some photographs, and you hand it to the owner, to the contractor, and say, great, go find it. Now the roofing contractor would have to basically, this goes the same for building enclosure, you have to play cat and mouse. Now they gotta go look at your photos and figure out where that's at on the roof, where that's at on the elevation of the building. So we actually mark it on our satellite images, 1, 2, 3, 4, 5. Here this roof is relatively new. So here's a 1, you show a photo of it, but right here it tells you what to do at number 1. Above and beyond that, we mark number 1 on the roof. This is really paint by number. So this document becomes very usable, not only to the owner, but to the contractor. So your repair costs actually should be reduced because the contractor's on site for a much shorter duration. They can walk to it. Before they go on the roof, they already know what needs to be done. what kind of roof it is, modify the roof, I mean, these types of roof materials, manufacture. So it's a much more usable document than we saw in years past. So this concludes what I have to say tonight. I appreciate the time. It's good to see your faces. Anyone have questions? Listen.
Okay, this is $64,000 question. What is your favorite roof and why?
I love that question. None. No, I'm kidding.
No, you gotta have one.
Yeah, so honestly, I do get this question a lot, and the first time it stumped me, oh my God. It's like having a favorite kid. Structurally sloped, metal deck, probably EPDM, honestly.
No way.
That being
You
said,
get a leak, you gotta find it.
well, that's easy. That's easy.
Yeah, but
Structural slope is the biggest, and here's why. You're always going to control the water. Code upgrades aren't a big of an issue because you're having open end or gutters or scuppers, so you're forcing the water off the roof. So later in life, code upgrades shouldn't be an issue. The water sheds quick, so it gets off your roof quicker, so you should have longer life expectancy. I'm saying like 1/4 inch slope, nothing great. Pushes the water off. When it comes time to re-roof that, all I need is flat stock or a cover board. I'm not buying a tapered system. If I have a metal deck, I'm blowing fasteners to it. I'm not buying expensive adhesives and things of that nature. So in all reality, as somebody who owns commercial properties, starts to slope metal roof, don't even really care about the roof surfacing. The reason I do say EPDM, it's much more walkable, it's safer. It doesn't take a lot of slope for a TPO or PVC roof to be extremely unsafe.
What about welded seams that you get with PVCs and TPOs versus glued seams you get with EPDM?
It's a great point, especially without slope or a low slope situation, less than 1/4 inch per slope. What Chip's referring to is your TPOs, your PVCs require a heat welded seam, which basically creates 2 sheets and makes them monolithic. They will not separate if they've been welded at the proper temperature for the appropriate duration. Once that happens, our sheet from one end of the roof to the other should just be monolithic. No seams, no failure points outside possible penetrations. Do love that. It's great technology. When we design it, we will not allow a peel and stick accessory on that roof. One of the things we find a lot with contractor-driven scopes is they'll specify a TPO or a PVC, and that's great in the field. They get to our gutter edge or our scupper, and all of a sudden they want to use our adhesive-based peel and stick products. We're kind of killing ourselves here because that's where all the water's getting in. That's going to be our failure point. That's the area receiving the most abuse. And now we kind of step back from the real benefit of these membranes. In regards to the EPDMs of the world, a lot of them were 20 years ago, it was kind of what they would call a field fabricated sealer lap. You just had big sheets of black rubber, you'd have to clean it, you'd put glue down, and then if you were lucky, you were going to put some sort of peel and stick into it. A lot of them will come with pre-manufactured tape already installed now, so we're seeing a higher success rate, less failures post-installation. The reason for that is manufacturers want to make these things error-proof because they don't want to pay warranty claims. So the more they can do in the factory versus in the field is where everything is headed. And it's not just in roofing, I think that's
Self-adhered versus putting glues down.
exactly.
More in the factory. You know, you talked about climate conditions and cold weather. When you fabricate more in the factory, you're taking away those field mistakes that can happen with a contractor at 25 degrees on a Friday afternoon and needs.
That's exactly it. I mean, they're finding ways to make these roofs easier to install with less manpower. And unfortunately, that's just the way it's going to have to be moving forward.
So it's not good for union labor, but
It's really not. That's a topic for another day. But, there are well over 250,000 different roof components. It starts at the decking, works its way through the finish, the membrane, whatever it might be, accessories, manufacturers, colors. They're all there for a time and place. And that's not even associating the fluid applied, the coatings, and things of that nature. They're all in the industry for a reason. They're just a time and place. There's not a panacea. That's why I didn't get into roofing 101 or the types of issues we find on roofs post-construction, because every one of those types of roofs has its own failure points.
International leak detection, EFDM, CTEC, scan, thermal scan. What are your thoughts on that?
As far as I know, we're the only firm in St. Louis that performs any of those. Our closest competitor would be ILD out of Chicago, and those things have recently changed. We started performing electronic leak detection, not electronic field vector mapping. That's a coined term by ILD, or International Leak Detection. It's like calling soda Coke, basically. We perform high voltage and low voltage electronic leak detection. Again, there's a time and a place for it. It works amazing. We love it. Unfortunately, it typically works in waterproofing applications and things that Jeff are going to be dealing with, not roofing. The reason for that, per ASTM D7877, your waterproofing membrane has to be directly applied to a conductive substrate. Okay? So that's not metal deck because you're never going to see insulation. Yeah. So if we can adhere something to concrete, like a roof, PVC, glue it straight down, it's great. It'll function. High voltage, low voltage. We love high voltage, and I can show you why. We have test beds. Come to Webster Groves or our office, we'll show you. They're awesome. When we start adding the insulation, there's always been this argument that it becomes saturated enough that becomes conductive. Well, that's inaccurate. In fact, the amount of water that has to be in that hole to create saturation through all of our closed cell polyiso insulation is too significant. We've done testing. It doesn't work. Works amazing in waterproofing applications. High voltage, predominantly because it's dry, so it's a lot easier to use on vertical surfaces. We own Buckley's equipment, which was the first equipment manufacturer outside of ILD, came from Europe. We bought that about 7 years ago. High voltage and low voltage. We have the DTEC equipment. We do low voltage. We actually design and specify their true ground primer. So if we talk about a roof application, as a designer, to make your electronic leak detection system functional, we have to find a way to make between the membrane and the insulation conductive. Not easily done. There was wire meshes and things that were installed. The problem with that, the manufacturers wouldn't support it. So we'd rather have a roof that functioned or the capability to find a leak that's already existing. These leak detection systems don't predict the future. They just help you find it already. And unfortunately, the people I hire can find these leaks. It's not an issue. Now, the true ground primer is interesting because all right. On a traditional roof, polyiso or metal deck, which is probably the most common thing we're seeing in this market, this paper facer up here, the top side of the insulation. You can install this true ground primer. All it really is carbon black and adhesive. Flashes off. All the manufacturers, for the most part, are either testing it or approved it. If they haven't approved it, they're just in probably lining weeds waiting to get approved. It becomes black. Once it becomes black, you glue your membrane to it, it now becomes conductive. So it's a great tool. Unfortunately, it's a misnomer that it works in commercial roofing. It just doesn't unless DTAC and some other type of materials or products are involved. Are you familiar with it? Have you guys seen it?
I worked on a new spec section for it recently, and it was a DTEC spec.
Yeah.
It took them a while to decide which DTEC system. I wrote options for both of them.
Yeah. They have a leave-in system, which is kind of crazy. Again, it doesn't predict the future. We've been in Seattle with Sean and his team, training through all of this. It is great. Unfortunately, the majority of electronic leak detection specs we see, we build mock-ups and show them how it can be tested. So we built 2 different test beds at our office. We can transport them. We can bring them here. We can bring them anywhere. We bring in the test equipment. We show people how it works, why it works, and why it doesn't work. It's great. Love to see people specifying it. Flood testing is archaic. It's laughable. If at all possible, electronic leak detection should be specified. But yeah, if you want to circle back and chat with me or show you guys how it works, we do it all.
I got one more.
Yes.
Okay. I've done a lot of rules. And I'm the only one with this opinion. But I need somebody else's opinion. I've never done one black roof in my life. Here in St. Louis.
Okay.
I've all done reflective white roofs.
Okay.
And the other so-called designers and engineers tell me there's no difference. Do you have an opinion?
My opinion is based on science, first of all. This isn't a personal opinion. Based on the heating costs, specifically in St. Louis, but the surrounding markets,
Yeah.
It's going to cost more to heat a building than cool a building in most settings. If we break beyond about 2 to 3 stories, you're losing more thermal gain, you're losing more efficiencies through the walls of the building than you are the roof. We have issues with glazing, a million other things happening. So the only time I really find it effective is a 1 to 2 story building where it's designed properly on the outside, something newer, and you're really not gaining The whole white roof thing really got pushed out of Mayor Daley in Chicago. Science has proven now that was complete garbage and never should have happened in Chicago. Now in Phoenix, in Florida, it's amazing. Yes, it's a totally different world.
That's stubborn.
No, it's net neutral. So when we talk about the gain, black or white, yeah, it's indifferent. Now what you do gain, if it's done right, is our welded seams. So we have a monolithic sheet. So there's huge gains there. Most of our TPO designs are actually gray because the white roofs don't last white for long. And the gray really actually kind of look nice. We go back, and I'm a roof nerd, so it's awesome 2 years later. White looks pretty rough 6 months later.
Speaking of the white versus gray, the dome downtown, it's called now.
Yeah, I do
They were
too.
hosting the NCAA tournaments several years back, and I happened to have a desk on like the 23rd floor overlooking it. And the week before the tournament started, they were scrubbing it down and whatever. And here's the thing, they only did half of it. Half of the blimps off.
And that's a great thing to mention too. When we talk about white roofs not staying white, we've had contractors and especially government agencies enforce that we need this reflectivity index to be met, which is crazy. It's not going to last. You can wash a roof with a power washer, but it has to be quote unquote low PSI. I've never found what low PSI means. I know the smallest power washer you can get is about 1,000 PSI. So we tell people if you're going to power wash it, the light bristle brush with 1,000 PSI, no more, and obviously keep your distance from the membrane. Anything higher than that, you'll cut through it. And as I mentioned earlier, we only got about 20 mils, which is a couple sheets of paper of waterproofing. So the power washers I've used that I've tore stuff up with, would scrape right through that 20, 23 mil pretty easily, and not created damage. I've actually been on a roof, you might know this, where they were using buffers. So they took a salt pad, kind of a mop type head, put it on a buffer and buff the roofs. I'm totally against all of that. You catch one piece of metal, one screw, and it gets caught in there, you create catastrophic damage. The reality is it's a roof, it's going to be exposed. If it really needs to be aesthetic, there's a million other things we can do. We can coat it, we can paint it, we can ballast it, so many other things.
They were cleaning it, as I recall, with brooms by hand, and it worked well when they were at the top of the.
Yeah.
The further down they got.
I love that story though. Half of it.
Yes, absolutely.
You mentioned cold weather installations as being a particular problem. How about hot weather installations?
Yeah, totally. Your flash times change a lot. You need to make, if we install a roof now versus 6 months from now, either direction, it's different dynamics. You need an experienced crew to understand how those adhesives are going to flash. Another big component with that is we're using a lot more float applied flashings. Some of them are catalyzed, some of them are not. So it's kind of you're making a cake on the roof basically, and it's got pot life and kettle life, and the humidity can actually affect how you catalyze those resins. The other part of that is we use a lot of we have a concrete deck, predominantly concrete deck. We're going to use like a low-rise spray foam to adhere our insulation or substrate. That really gets affected by heat. In the cold, they can actually heat it and do some things with it to make it rise faster. I compare it to the stuff we put in our rooms, the great stuff, the foam. You spray a little bit, it expands. This stuff does the same stuff. Well, if you ever get a can of that and you spray it when it's cold, it doesn't rise the same as it does in the heat of the summer. So all these things are affected.
It goes too quickly in the summer, right? Very quickly.
Yeah, the interesting part is once it rises, you have to lay your boards into it immediately. And again, during the summer, it's a lot shorter window. During the winter, you'll see guys spray it, walk off, do some other things, kind of keep an eye on it, come back over. We've seen it rise so fast in the summer, they have to scrape it back off and reapply because it just didn't blow up on it. Once it blows up, it's no good. That's the only thing I can really think of in regards to the heat aspect of it. The weldable seams are kind of an issue in the fact that you have a control welder that has to be calibrated. They need to do test sampling each time they fire that sucker up. And it can be sped up or slowed depending on how quick it's welding. And if there's a cover board, which is gypsum, that actually reflects the heat. So it's going to weld at a lower temperature. We've seen guys run right off of a piece of gypsum onto a piece of polyiso and not adjust the welder. And you have failed welds, cold welds is what we refer to. So the welding's a big deal. In the winter, you'll find guys that say we're going to slow it down and crank it up as high as it'll go. Well, that's not good either. You know, there's a nice point there where that weld is sufficient and it's adequate. If you go too hot, you've melted it and you've lost that monolithic benefit of the TPO PVC membranes.
I have a question for Jeff. Line. Yeah, get up there so we can catch you on the microphone. So I go back to the days when urethane sealants were the way to go. And silicone came in and pretty much took over the market. And I'm talking about all sealants. Where toward the end of my career, when I retired, the only urethanes that I was specifying were outside for slabs, you know, and that sort of thing. So I'm assuming urethanes are still state of the art for that, state of the art for where you have submersible seals. Is that correct?
I still think it's a cost situation as well. Some owners don't want to pay for the silicone and they'd rather pay for the urethane, and that drives it as well. I remember early in my career, Walker Consultant came to me and they said, Jeff, you know, it's something that you need to understand about how you guys price your jobs out. You always want to use the best materials, the highest priced materials, and you know what, not every owner wants that, and so sometimes you're better off going with maybe the mid-price Chevy and really worry about the contracting experience. Start the job on time, finish the job on time, do it safe, good quality, but you don't always have to do everything with the best products. And so I think we still sell a lot of the urethane products out, and I think it's maybe driven by the cost as well.
So do the silicones work for the type of joints you were showing?
Oh, as far as on a concrete
Yeah.
surface? No, because the urethane won't bond to the silicone. So we would not use a silicone on a park garage. They're not compatible.
Okay, you talk about the coating with
Right,
bond
right.
and seal.
Right. And typically, we don't put silicone in on the concrete. I would say vertical, yes, if there's application where you see that, but very rarely do we put silicone on the concrete.
I'll add that.
Since you taught me all I know about sealants. Yeah.
I always have soapbox on that, right? Is that, you know, silicones, yeah, the life expectancy manufacturer issues 20-25 year warranty. Problem is, if you put it horizontally, what are you doing? We're walking on it, we're driving on it, we're shoveling snow on it, we're steel plow, snow plow on the top deck on the slides Jeff showed. Bottom line is, you'll never get the effectiveness of, you'll never get the useful life out of silicone horizontal because you're tearing out. It's going to get tore up. It's probably going to be tore up from a mechanical means and all the traffic means before the weather's out if it's Europe. And exactly, so maybe you can't put a urethane traffic coating over silicone.
When they handle high heels, are they able to ground that? Can they are they strong enough to do so? I know they're more flexible, but I don't know if they'll handle that traffic.
They also don't handle freeze-thaw at all. Water gets in it and expands and pops inside of the bead. I've seen that happen quite a bit.
A problem with the silicone too in the past, and maybe it's different now, but they collect dirt more so than a urethane will. And you just go and take your fingernail and scratch the joint, and you can tell if it's silicone or urethane.
All right, well, I think we've kind of run through our time. I want to thank our speakers. Thank you very much for being here tonight, joining us, and giving us benefits of your experience and wisdom here. So I appreciate it. I'd like to thank everybody who came tonight. Thank you, everyone. Thank you for coming to join us online and in person. Thank you.
Thank you.